Thank you, guys. Okay, cool. So the first thing I have to tell you, it's really funny. This is the first time in, I think, a decade that I get to use this clicker, because I haven't been on a stage this large in ages. And over the course of the pandemic, it turned icky. It's like the whole plastic is sticky, and like, this is amazing. So like, I'm just gonna, keep going. So hello, everyone. Thank you for attending my talk. Thank you for sticking around. My name is Christian. I'm gonna present to you an open source project that I've been working on and with for a long time. A couple things about me. So I am currently the tech lead for this project, which means that I get to influence the technical direction for this project a little bit more than I did in the past. I am not at home in the observability world. I have learned a lot about how you guys think in the last 2 days, but I am very at home in the network monitoring world and in the network security world. I am a recovering academic, so for about a decade, we used to write papers sort of in the network architecture, network security, network monitoring space out of a lab in Berkeley, where we also worked on Zeek a lot. So a lot of the research that we did over those years was basically enabled by that system. And these days, I work at Corelight. We're an open core company. We're basically commercializing Zeek and related open source technologies. And I feel very gifted in that I get to work with a team there, my team that is fully dedicated to basically advancing Zeek in that company. So that's great. So I'm just gonna ask, like, how many people here know Zeek? There are some arms. Okay, this is awesome. But other than that, I have come to the right place, so good. So you guys are pretty technical, so I'm going to spend sort of most of the talk on a technical dive into what the system does, and then I have a little bit about use cases for it and a little bit about the project itself, and that should sort of come to about half an hour. So it all starts with DPI. So DPI, Deep Packet Inspection, is something that I'm sure many of you have heard of, but I'll just sort of cover it anyway. And it means technology where you basically grab every single packet that goes by on the wire, and you basically parse as deeply as you can into it and sort of build up state around the connections that you see, what is going on in these, and so forth. And so I'm going to be building up this architecture diagram sort of from the bottom, and the first thing you have to figure out in Zeek, hope you guys can read that, is like with many network monitors, if you want to process traffic live as it sort of like flies by, or if you want to process traffic that has been canned and basically like recorded in a PCAP. I'm sure almost all of you know what PCAP. This is basically literally taking like every packet that flew by and dumping it into a file. So Zeek can operate in one of those two modes. And everything in there is pretty pluggable. So if you have, a particular networking card or use particular hardware for this, then there's a good chance that we can support whatever you have. And we ship by default with about 70 protocol parsers that sit on top of this, that basically do this DPI parsing that I was just describing. And the way you can picture this is that basically in every analyzer, there is parsing happening that is sort of appropriate for that protocol. And the next thing that we are is a distributed event-based system. And what I mean by that, I think here too, you guys all know what an event-based system is. It's basically one where, the code flow is not predefined. It basically sort of happens driven by events that come into the system. And of course, network traffic is a really good example of that. And so what happens here is that whoever writes an analyzer for a given protocol basically defines what are good events, natural events sort of in the lifetime of that protocol. Those don't have to have usually don't have a security context. We don't make assumptions about what is benign or malicious. This is just about what is happening. So for example, in TCP, that could be when a handshake gets established, or for DNS, it could be a transaction. For DHCP, it could be a lease that gets dished out, like stuff like that. And whenever such an event happens, we basically sort of shove it into an event engine that has a queue, and that you get to sort of just have sit there for a little bit. And so here are a couple of examples of what these events look like. So this is looking a little bit like a programming language, which is sort of foreshadowing where I'm about to go with this. So this is a really common event in Zeek, which means that a connection has been established. This is basically when a TCP handshake is complete. We also use that to describe UDP flows, for example, so connection isn't sort of super technically correct, but it's a detail. But what matters here is that this thing has a name, and it has a list of typed arguments. Here's just one. It's a connection, and a connection is sort of a record. It's sort of an object in Zeek that basically collects information about the endpoints and so forth. So this is a really simple one, but a very common one. This is a more complex one that is out of the TLS analyzer. We call it SSL for sort of historical reasons. And you can see that it has a lot more arguments that are typed and sort of basically reflect what happens when you get a client hello in a TLS connection. And so these are two examples of, I think, about 500 total. So over the years, you know, a bunch of stuff has sort of built up. And these are all things that you can hook into if you put together an analysis that cares about these events. And I was sort of like just saying that it looks a little bit like a programming language, and that is sort of yet another thing that is Zeek. It also ships with its own scripting language that is basically a domain-specific language for analyzing network traffic. So it has really nice features for representing addresses, for keeping state, for dealing with connections, and so forth. It sits on top of the event engine in a script interpreter that is very sort of configurable. It's largely procedural. It has a notion of event handlers that I'm about to show you, and is otherwise looking sort of strongly typed. Not unlike what you might know from C or Perl or Python or what have you. Let me show you an example. So this is a small Zeek script. It is fully functional. You could dump that in a file and run it. I'm about to show you what that looks like. And the details don't matter too much here, but it's just sort of to give you an example and to give you some intuition of how these things work. So in the first line, you have a global. It is a set of addresses. Then you have an event handler for this connection established event that I was just showing you. And in it, you define what you do with this event. And here you just see that in this particular language, you add the originator of that connection. This is sort of this cryptic looking part there in the square brackets. Gets added to that set. And in another event handler that sits below called Zeek done, where the whole thing basically shuts down, we just have a print statement and then iterate over that set and dump it all out. So it's really pretty straightforward. And so if you run that, it would look like this. So you can run it on a PCAP, like I described earlier, and assume that I just took that script and dumped it into awesome.zeek and run that, and then you get something like that. For the test PCAP that I used, this was the actual output. So I already asked how many people know Zeek, so I don't really need to ask how many people know the Zeek scripting language, and how many people know JavaScript. I have good news for you. So we're about to come out with Zeek 6, which is our latest major release. It probably comes out actually next week. And this is the first time in the history of the project that we're sort of branching out from the original scripting language for the exact reason that we could just demonstrate that basically it's yet another scripting language that people have to master. And there is just a lot more awareness and familiarity with JavaScript. And it is, I think, quite fascinating to me that we were able to add all of that support within Zeek without actually changing Zeek itself. This is all done within a plugin structure that exists in the system. And the exact same script that you just saw would look like this in JavaScript. So it is very much the same. I'm not going to go through it line by line, but you have all of the equivalents of what I just showed you in Zeek script here in JavaScript. So you have the set, you have event handlers, you add state. When you're done, you dump the whole thing out. All that changes is that instead of .zeek, you can now say .js, and you run it, and it looks exactly the same. We think this is pretty exciting because it should make it much, much, much simpler. This is based on Node, by the way. I didn't say that, but if you saw the .on and so forth, you probably could figure. So it's pretty exciting what that should enable just because of the vastness of that infrastructure and that ecosystem and all the stuff that's there. All right, the next thing that Zeek is a log writer. So I told you that the script layer is very configurable, and so there's this question about what does Zeek actually ship with by default? What does the script layer actually do by default? And by default, we basically give you really good logs about what is in your network traffic. And so the way this works is that we have sort of this one standard log that we call the con log that is sort of like NetFlow on steroids. So if you know NetFlow, you know it as sort of a per flow connection summarizer, and that is basically what this is. So it tells you the endpoints of a flow, it tells you which endpoints were local to your network, it tells you how many bytes, packets, and so forth were transferred, and it tells you what protocols and services we found in a given connection. And so that's sort of the hub of our logs, and then there's a whole bunch more. You get about 60 of those. And you can think of those as sort of a combination of, first of all, sort of protocol-specific logging, and then also sort of related concepts that you find useful. So for example, there's a files.log for all files that Zeek was able to recognize in the protocols that it can parse. There are logs about sort of strange things that are happening in the network traffic that don't look quite right, and so forth. And to come back to the architecture for this a little bit, so on top of the script interpreter, if you will, sort of going back into the rest of the architecture, there is this logging engine that is, again, very pluggable. By default, we log to files. Most people these days will want to use JSON. There's also a historic sort of tab-separated format that you can use, but there are plugins for lots of other exporters. So a lot of people, we're working with Pump into Kafka. For a lot of other people, it's Splunk. We really like Humio, now Logscale. So it depends. I've noticed that in different fields, there are sort of different preferences for what is a good log ingester, but I would actually stress that there are certain benefits in actually sticking with old school text files. We know lots of sites that have like years-long archives of text files because they can always go back and process those files really nicely, no matter what is sort of the data ingestion technology du jour, right? So it's incredibly powerful. An aspect here that I wanted to flag is that, you know, I didn't show you how the logs actually come out. So as part of this invocation that ran here, we didn't just get this output that we programmed into the script layer. This other stuff ran as well. So I got this bunch of logs in my directory where I was running this, sort of highlighted in bold there in the bottom right. And this is all basically logs for the stuff that was in that little PCAP that I ran there. And if I go in and, for example, like look at the conlog example, then I can't quite tell if you could see that earlier in the example of this table that was describing the conlog. But in JSON, you would see that this is basically the data that are here for this given connection. It matters that the second thing up there is this string that looks sort of cryptic. But for example, if you look for this string in the other types of logs, then that gives you a really nice sort of, you know, anchor point to pivot from one log to another. So you can string together all of the things that related to the same connection, for example. So it's quite powerful. And a final aspect to flag is that the whole thing is designed with a pretty strong separation of policy versus mechanism. So all the parts that are saying mechanism here basically will always do the same thing. It's really just in the script layer that you define what you want the system to do. Like I said, by default, it gives you a good log writer. You can build other things with that too. Like some people build detections, other people build sort of anomaly detection models and so forth. You can go pretty wild. And this whole thing that I sort of painted here is one Zeek process. So if you just run Zeek like I just did earlier on that PCAP, then this is all the stuff that kicks in, so to speak. And if you remember that earlier I said Zeek is a distributed event-based system, then you might go, where's the distribution, right? This is just one process. Nothing is distributed. There was one event queue and you were done. And that is because, especially if you monitor live traffic, you do not normally just run this one process. You run a cluster. And so the way that looks is that every blue box here is basically one Zeek process. You run a bunch of those. They basically get different roles. So at the bottom here, we have what we would call workers. Then there's this thing that we call proxies, which are basically sort of relay nodes. There's usually, you know, one manager on top of this and one logger, although you can have multiple if you need that for scalability reasons. And the key part is at the bottom, you have a network tap or a network card that understands sort of how to divide traffic up into queues. And then each of those workers sort of sits on one of those queues and does traffic analysis. And then we use PubSub, event-based PubSub, for Zeek events to basically communicate the rest of that stuff across this cluster, so that, you know, the analysis happens, you know, as needed. For example, sometimes the proxies and the manager will want to have some sort of like centralized state, and when some script in one of the nodes in that cluster decides it is time to log, you know, an entry to a file, then it'll send an event over, or more specifically a message, it's not all events, to the logger, and that thing puts it out. And so that's then a Zeek cluster. And for most people these days, you can run this on one machine. You can have machines with an incredible number of cores these days, but this architecture sort of dates back to a time where if you wanted to run something on multiple cores, it basically meant you had to run it on multiple machines. And so in the larger sites that we're working with, those guys tend to actually run really a cluster of machines because that's the only way they can handle the load, and then you need a load balancer, a device that basically takes your network traffic and divides it up and sends it to that set of machines. Okay, so that was Zeek. So what is Zeek? So Zeek is a mature, extensible, distributed, event-based, scriptable network data logger. That's everything I could think of sort of and put it in there, which is why I love to work on this, because it's really kind of cool to have one thing to work on that is all of these things, like a network monitor, a distributed system, a programming language, so you can sort of iterate through things, but it's also clearly a mouthful. So a couple more analogies. Zeek is a lot like longitudinal TCP dump or Wireshark or T-Shark or whichever of the packet recording tools that you're familiar with, except it's more focused on the flow level. So if you use Wireshark, then maybe you know that you sort of like usually like open up a small PCAP and you like dig into the headers of particular protocols. Zeek is sort of the same, but for all of the traffic and at flow level. You don't really care about packet level activity so much. You sort of abstract to the stuff above it. Another analogy that I really like is Zeek is a lot like eBPF tracing. So if you make an analogy between all of the events that it gives you and eBPF trace points, then it's actually very similar. You need to figure out sort of which of the ones matter to you, what code to run when you hit that, except I would argue that it is much easier to do in Zeek than, especially given the JavaScript ability that I just showed you, than eBPF, but the analogies I think are pretty strong. And more than anything, this is Zeek. So if you want one thing in your head sort of that you will remember, then it's a network flight recorder, because for most of the sites where we know, Zeek is running, that is really the model or the reason why they use it. So you capture a lot, but not all of the data in your network, and when something goes wrong, you go in there and you use that data to figure out what went wrong. Okay, so if you want this one image, that's sort of it. Zeek is a lot more. I'm not going to go into tons of details about this, but there is this whole ecosystem of things around it that we've built out over the years. And just very briefly, there's a package manager for that script layer that I told you about. So if you write something that you think is useful, you can basically write a little package. We can add that to our standard repo of packages, and then other people can use that on the command line with a package manager that is very much like DNF or apt or whatever you're used to. This can also include plugins, so native code. So you can really write these packages to fundamentally extend Zeek, so to add a new NIC driver, or to add a new output module, or to add a new detection, sort of what have you. That's really sort of where the open-endedness of the whole system sort of pays off. There is a thing called Spicy that you should know about if you ever write parsers for network protocols. I don't know how many of you guys do that, but this is basically another domain-specific language. This is one that basically can capture the syntax and the semantics of a network protocol sort of concisely, and that gets compiled to something that can run in other systems. In this case, it compiles to C++. And does that in a way that is basically designed for streaming data, because that's sort of what defines network traffic. You get sort of data coming in chunk by chunk, and you need to make sure that when you access, the umpteenth byte in a buffer, that you can actually do that safely and not blow out the buffer and so forth. And that's exactly what that gives you. And it's beautiful because it is not actually built for Zeek. We're using it in Zeek, but we're, for example, also talking to the Wireshark folks because they might start using it for some of their dissectors, as they call them. There's Broker, which is our message broker, which is the thing that enables the cluster communication that I showed you earlier. And I wouldn't otherwise call this out here because it's sort of an internal detail, but there are language bindings just for that, for example, in Python and Go. So you can use our bindings to basically communicate Zeek events from other systems, like with a running Zeek cluster, which can be really useful if you have, like, in Python, some ML model trained, for example, or something that, where this particular ecosystem is really good, but in Zeek script itself, it would be nuts to build that from scratch. So you have ways to extend it that way. At the bottom there, I'm mentioning some cluster managers because if you run a cluster like I showed you earlier, then you want some infrastructure that makes that easier. And down on the left here, I'm mentioning Zeek Agent, which is basically our first sort of foray into expanding beyond the network. So the idea there is that you can run agents on Linux, Mac, and Windows systems that basically hook into the host level activity and still generate Zeek events. So you can basically then link, what user created a network flow and so forth. But this is kind of new for us. We're sort of like, exploring the first sort of deployments of this. But it's quite exciting. So I just wanted to convey that there's a little bit more going on here than just sort of Zeek itself. All of this stuff is BSD 3 licensed, so it's very liberal. You can basically take this and almost do whatever you want with it, including commercial use. I think this is sort of our heritage out of Berkeley. We just sort of strongly feel that that is the right license for open source software. Okay, so that was the technical deep dive, and I did not look at the clock. I'm sure I will be reminded when I'm running close. So a couple words about use cases. So the main use that you probably already sort of gathered here is better network data. And if you think of like how people normally capture network data, then there are really sort of only 4 ways in which that is done. So the most traditional is PCAP. So like I said earlier, take every single packet on the network and dump it into a file, right? So you have perfect data fidelity because you're literally capturing everything that was on the network at crazy data volume because you're recording your network. So there are only very few organizations that can do this at any reasonable scale for any reasonable amount of time, and even then it's incredibly wasteful. And then you have sort of the absolute opposite, which is good alerts. So this immediately makes assumptions. So now you are assuming that you care about detections, you care about alerts where there is some built-in assumption that something bad has happened, for example, and you might get that sort of like represented very well in this like little nugget that is this alert, but you're missing all of the context around it, like what led up to that, right? And then more commonly there's crappy alerts, like basically the same thing, but at crazy volume, right? Like there was a great talk yesterday about alerts and what they smell like and so forth. And then I touched NetFlow, and that's basically sort of the closest thing there that's sort of, generally useful. And the beauty of Zeek is that it sort of like sits all over the place in there because you get to decide how you want that to be. And because you write code that defines how you collect the data, it also means that it isn't fixed. So for example, you can start collecting network logs that are pretty coarse, that are relatively abstract. And in security incidents, there's a common pattern where, once something starts happening, it remains pretty localized to that network because like some attacker sort of like pop one box and then sort of manages to start jumping around a little bit, especially with viruses that were spreading sort of autonomously. That was sort of a classical thing. So if you get sort of, for example, first indications that something might up, then in that corner of your network, you can start to look more closely because you can adapt. So the whole thing isn't as fixed as with any of these other models, which I think is very beautiful. And so what is that used for? And so like I said, I sort of come out of the security domain, and this tends to turn into acronym soup, but you'll hear things like, network traffic analysis, network security monitoring, network detection and response, digital forensics and incident response, threat hunting. And I think these are all true and they're cool things and you can read up on them, but especially for why we're here, it's sort of the stuff in the middle there that I think matters a lot more. And it's sort of this triad of observation, validation, and discovery. And I have a really nice anecdote from a colleague of mine. His name is Richard Baitlick, who I don't know when it was, but at least a decade ago or so was charged with basically securing the GE, General Electric network, right? And so this is, I think, far more than 10,000 endpoints, vast network. How do you start? And he did not start by, like putting firewalls in place or intrusion detection systems or enforcers or what have you. He basically took Zeek and deployed that all over the network for a year to just learn how that network actually works, because in most large networks, nobody has like the map and then you know how this thing works. So you learn, and once you've learned, then you start thinking about enforcement and so forth. So I think this is a nice sort of concise way to think of like what you would actually do with the data. A couple words about the Zeek community. So it's kind of interesting. We have very sort of different sets of users. I sort of categorize them as security teams here. That makes sense, again, from the examples that I just gave you, but also network operators and then observability engineers. So basically they all sort of come to this, but with sort of slightly different intentions. And where it gets interesting is that all of those folks bring very different skills. So for example, network operators usually know their network like nobody else, but they tend to not think of themselves as developers. So if you give them the ability to script an analysis on top of 500 different types of events, they often go like, that's great, but I'm not going to do that. So this is where we're hoping that this package ecosystem can help and so forth. And this is sort of similarly true for these other groups here. And who's using Zeek? So this is sort of a classic, logo slide. These are all folks that we know are using Zeek because either they've told us at our own user conference, or because we've inferred that from job postings or just talking to them and so forth. And perfect. That's great. Thank you. And I want to give a shout out to Microsoft. I don't know in which talk that came up yesterday or between which talks yesterday, like look at what happened to Microsoft. This is incredible. So you might have heard of Microsoft Defender for endpoints, their security solution for endpoints, and they figured that they wanted a way to also record and analyze network traffic that is passing or traveling to and from hosts where Defender is running, and they settled on Zeek because they realized this is basically already doing exactly what they need. So this is from one of their blogs, and not only did they make that decision, they also decided to basically open source that whole contribution. So we were able to work with them because none of us in the team is a particular Windows expert, and we were able to work with them to get that to run and build, and that got merged in the second half of last year and is currently in our most recent release, which is 5.2, and so people running Windows can actually at least given this, like start to explore that system in that OS where otherwise we wouldn't have had a chance. So kudos to Microsoft. We all thought that was incredible, and that is a continuing relationship. They're doing more stuff now with it. Very exciting. Couple words still about the Zeek project. So I have alluded to the fact that we've been doing this for years, and I wanted to show you, just how many. So in the Zeek source tree, there is a file called changes, which is basically an old school changelog. And if you go in there and you tail it and you go to the very end, then you get there. So like 1997. So I'm here talking to you about a project that has been out there for like 25 years. I think that's pretty cool. It's sort of gone through many changes, and it took a long time, I think, to gain traction outside of that small little academic bubble in which we were working. And this is a photo from the Usenix Security Symposium. I don't know to which extent you guys are familiar with this. This is hosted by an organization that is very much into open access. You can just go to their website, pull up papers. It's an incredible conference. There's crazy stuff in there every year. I highly recommend it. And they do these Test of Times awards for things that basically have proven their worth. And the man you see there in the middle is my colleague and former boss, Vern Paxson, who started this thing in 1997 at Lawrence Berkeley Lab. And he, whatever that was, 25 years later, basically got awarded for this thing that is now basically being commercialized. Like it was rather ahead of the time. And if you look closely, it says there that it was called Bro. And so we renamed it about 5 years ago, because back then this was sort of an innocent pun on like Big Brother is watching your network, right? And I remember, I think it was about 6 years ago, the head of marketing at the time at Corelight was in a call, and I sort of walked by him as he was sitting on the couch, and he's sort of like, yeah, so I don't know if you've heard, but we're commercializing this network monitor that's called Bro, and it's like, yeah, no, it really is called that, and like, yeah, so, and it basically derailed there, and it basically got to a point where like VC funding would not have happened, for example, if we're talking about a thing called Bro, and very justifiable, right? So, but if you're ever wondering, or you see old material, it used to be called Bro, it's now called Zeek. Zeek is a pun, it's not a pun, it's a reference to the user account under which Bro used to run at Lawrence Berkeley Lab in the very early years. It's a Far Side reference for a dog, it's sort of a crazy story, but now it's called Zeek. and that's that story, so now you know. There's a pretty elaborate project structure. We have a leadership team. If you're involved for a while, you can get elected into it, and then there are sort of sub-groups and so forth that are structured from it. You can read up on all of this on our wiki. Pretty cool. This is the core team. We're sort of 15, 16 people right now. About 7 of them do actual development, so we are small but mighty. It means that basically we're really busy, and the only way we can do this is because we take our liberty in when we release and so forth. This would otherwise probably not really come together. If I got you excited with this at least a little bit, you have at least 3 ways to get it. You can just run it straight out of Docker images that we publish. So do a Docker, run it Zeek or some such. You can pull down specific versions. We have binary packages for various distributions. We don't currently have distro native packages in any distributions. This is a bit of a bummer, so we can't be on like Debian and just sort of install it, mainly due to lack of cycles. If we find contributors who are willing to work on that, that is wonderful. On the Mac, we're on Homebrew. On the BSDs, we're in the ports collections. These are external contributions for which we're very grateful. Or you can build it from source, which is actually not very difficult. The link to the documentation is down at the bottom. You can just sort of grab it and take it from there. And that's it. Get involved. So I have sort of a typical slide here of things that I'm not going to read through. I'm just going to highlight 3 things. If you're interested in this at all, especially since I'm sort of talking to a slightly different community, come talk to us and tell us about your use cases. This is really critical. We want to build things for people that are actually, that know what they want to use this for, so we build the right thing. That is not necessarily a given. We don't know everything about these adjacent communities. Like, I'm completely new to this observability world, as I just told you. So this is important. If you want to contribute something big, this is just like with any other project, please sync up early so we can coordinate with you so it succeeds. And this is probably less relevant with you guys, but we are always looking for people who are testing our release candidates in their own clusters, in their own networks, and so forth. Should you be interested in that, please come talk to us, no problem. And with that, I'm done. Here are a couple links. You can find our community links there for our Slack and Discourse, the documentation, and so forth. So that was it. Thank you, guys.
Great, thank you, Christian. I will say I've obviously known of Bro for a really long time.
Right.
I didn't know it was actually short for like the Big Brother.
Yeah,
so,
it was sort of.
But also, thank goodness they rebranded it too, because I had many of those similar conversations of,
completely
wait, what is this tool? No, we're not using that. So, any questions? Any questions for the audience here? Yeah, we got one right here.
Yeah, how well would Zeek run in a resource-constrained environment like a Raspberry Pi?
Yeah.
So how well would Zeek run in a Raspberry Pi or resource-constrained environment?
Yeah, thank you for repeating the question. That is a great question. It is also, I'm going to punt a little bit because it's very hard to answer. It depends too much on the actual traffic that thing is monitoring. So a good example is, for example, DNS traffic tends to be a little more heavy because it's usually, at least if it's sort of traditional, many small packets. Small packets have more per packet overhead, tend to exercise the system harder. It totally depends. Something like a home network should be a no-brainer. It's also, like, no matter in what setting you run it, at some point this question will come up, like what can it sustain? And there's sort of a tuning phase that follows at this point. You can disable certain analyzers, protocols basically that you do not care about. There's often something like that. You can exclude parts of the network. Dicey, but sometimes reasonable. So it basically depends, and it is really hard to tell ahead of time, like even what the bottleneck is. It might be your logger, it might be like your workers, depending on how many you have, and so forth. So try it out and see where you end up, and then come talk to us. Like if you check our Slack, there are tons of performance questions in there, and we almost always figure something out. Yeah.
Awesome. Any other questions? One last thing. Yeah, we got some. Are there 2 different ones, or are you just really waving me down aggressively?
It's completely
Go for it. Do you support hardware timestamps?
Yes, because I think a lot of NICs give you hardware-based timestamps, right? Solarflare, I can't tell you right now. But for many of the packet sources, like our notion of this, that basically use the platform native drivers, the timing actually comes from the NIC. It's really only, I think, really old school PCAP or libpcap, packet capture that is like standard kernel power, that where the timing is not actually out of the hardware that captures.
Can you support it all using a specified field and add a timestamp in the packet?
Can you support a specified field as the timestamp of the packet?
That is a great question. That would depend. if we're doing the parsing, yes, because it's up to us. If it's something that is not accessible to us because it's completely buried in the link layer or something, or the physical layer even, right, then no. But usually that is the case, yeah. Like that we can get to it, yeah. Yeah.
Last call, any other questions? There's also a speaker channel in the Slack, obviously. You can continue the conversation there. All right, another big round of applause for Christian.
Thank you guys.